Hey everyone, in this video I'm going to be talking about mixtures and investments. So mixtures and investments are essentially going to be some word problems, and they're going to take advantage of the standard form of a line. So if you recall, the standard form of a line could be written as ax plus by is equal to c. So in this standard form of a line here, what it essentially means is you could think about this as some quantity A of X plus some quantity B of Y equals some known quantity C. Okay, and so that's the application that we're going to be taking advantage of in these mixtures and investment problems. And again, this is going to be combined with systems of equations as well, along with your ability to solve word problems. So these problems are going to be fun to take a look at. So I have three examples ready for you to take a look at. Example 1, 2, and 3. You could click on any of these examples here to take a look at them immediately. But let's go ahead and take a look at number 1 to begin. And then we'll see if we could take advantage of that standard form of a line to see if we could help solve the problem here. So number 1, at Kayla's Nut Shop, peanuts sell for $2 per pound and cashews sell for $5 per pound. A customer wants to buy a 10-pound mixture of peanuts and cashews and is willing to pay $28. How many pounds of each type of nut should Kayla use to make the mixture? First of all, when going through these word problems, you want to have a good understanding of what's going on in the problem. So if you have to read this again, go ahead and pause the video and take another look at what this question is asking for. And yes, I do know that peanuts are not in fact nuts, they're legumes, right? But the question is asking how many pounds of each type of nut should Kayla use to make the mixture. So in doing these mixtures and investment problems, it's a good idea to take a look at what the question is asking first of all. So the question is asking how many pounds of each type of nut. Okay, that's what we're looking for. That's our ultimate goal. And you better believe that what they're asking for here is going to be the variables that we're going to need to work with. So to begin a problem like this, you want to take a look at what they're asking for and define some variables that's going to help you reach your answer. So the question wants to know how many pounds of each type of nut. So we have peanuts and we have cashews. So let's take advantage of x and y. Let's just use x and y for the variable names. So we could say let x equal the number of pounds of... Now we have two types of nuts here. We have peanuts and cashews. So let x represent the number of pounds of peanuts. And I could say let y. Now we're also looking for the number of pounds of peanuts, and we're looking for the number of pounds of almonds, right? I mean, not almonds, cashews, because we want this mixture. So y could be the number of pounds of cashews. So this will help us solve the problem here. So that's a good beginning point. If you could identify your variables, which it's easier said than done, really. It takes a little bit of practice at looking at these problems, but usually these variables will come from what they're asking. So pay attention, pay very close attention to that. Now, next up, what can we do with this? This is the point, you want to read through again and see if you may be able to write some equations that involve your variables. So we know that the customer, let me skip over the $2 per pound and cashews sell for $5 per pound. You could write it down if you would like. I suppose I could write it down here. X is the number of pounds of peanuts. So next to this, I'll write that peanuts are $2 per pound. Okay, this is just helping me organize the information. And the cashews, it says, are $5 per pound, so a little bit more expensive. Okay, so this is separate information, but again, anything that helps you organize this information is good. Just, write it down. It's better than leaving a blank slate in front of you. If you just leave things blank like that, you're not going to get through the problem. So we should write down some of this pertinent information. Now, a customer wants to buy a 10-pound mixture of peanuts and cashews. Okay, so let's work with that. The customer wants to buy a 10-pound mixture. So this is where the mixtures comes in here. This is a mixture problem because we're looking to combine these two separate objects. Now, if a customer wants to buy a 10-pound mixture, then that means that he could buy a certain amount of peanuts and he could only buy a certain amount of cashews. Whatever he buys, since he's buying pounds of peanuts and pounds of cashews, this weight has to add up to 10 pounds. So we could write down something. Let me actually give it a name. We could write down a weight equation, right? The equation dealing with weight. Since x is in pounds and y is in pounds, we could say, well, x plus y, right? X pounds plus y pounds should equal, now what do we want? We want 10 pounds. So x plus y should equal 10. That sounds good. That's a nice piece of information. However, this by itself is not enough information to solve the problem. There's another piece of information that we need to take a look at. So another thing is that he is willing to pay $28. So there's a lot of solutions to this single equation here. If I said, well, if he buys 6 pounds of peanuts and 4 pounds of cashews, that satisfies this, right? It satisfies the fact that he wants 10 pounds. However, 6 pounds of peanuts would cost him $12, and 4 pounds of cashews would cost him $20, sorry. So total, that's $32, right? But he only wants to spend $28. So what do we do? Well, what that means is that, that's not the right weight of these peanuts and cashews. So we don't want to just, I suppose you could, set up a table and guess and check. However, if the numbers aren't very nice to work with, you may be there a long time, and we want to have a foolproof algebraic method to do this. So we don't want to rely on guessing and checking all the time. So we have this weight equation. Now let's see if we could incorporate an equation that has this $28. So let's think about this. He's buying X pound, the customer is buying X pounds of peanuts, and the peanuts are $2 each. So if you bought 1 pound of peanuts, it'll cost you 2. If you bought 2 pounds, it'll cost you 4. If you bought 3, it'd cost you $6. So how do we get that number? Well, we're multiplying this X pounds of peanuts times the amount of times the price per pound. And how much is he spending on cashews? Well, he's buying Y pounds of cashews, right? Something we don't know. We just write down Y. But for every pound he buys, it's going to cost him $5. So he's spending this amount of money on peanuts, and he's spending this amount of money on cashews. When you add that up, we're going to obtain, what do we want from this equation? We want it to equal 28. Okay, and if you're having trouble seeing that this in fact represents money, you may want to include units. Just briefly, I'll erase this, but for example, this the 2 times x, this is $2 times x, $2 times x pound. Oh yeah, it's $2 times x pounds. Yeah, is dollars, right? Because 2 per pound. So yeah, $2. Sorry, it took me a moment. $2 per pound times X pounds. We see that what happens is, since this is $2 per pound and this is X pounds, the pounds cancel when we do this multiplication, and what we're left with is 2 times X dollars. So this, in fact, does represent dollars, and the same over here. So if you weren't sure that this, in fact, represents dollars, you could throw in some units and see that it does, in fact, work out. So let me go ahead and erase this for now. We don't need that. So if you want, you could call this equation here the money equation, because it deals with our money. Okay, so here's the situation. In all of these mixtures and investment problems, this is going to be the setup pretty much. You're going to have two, you may have more than one equation, but we're going to have a system of equations, and if you notice, these equations are both in standard form. AX plus BY is equal to C. In this case, we have 1x plus 1y is equal to 10. That's the known quantity. And 2x plus 5y is 28, where 28 is the known quantity. And once we obtain the system of equations, we have two unknown variables and two separate equations. We're going to have the ability to solve this, as long as it's something called a consistent system. So I assume we do have that. So we could continue this to solve the system through either the substitution method or the elimination method, either way. But let me go ahead and use substitution. Since I know x plus y is equal to 10, I know that y is equal to 10 minus x. Okay, I subtracted x from both sides. And now I can make the substitution. I'm writing down my second equation, 2x plus 5, but instead of writing y, I'm going to replace it with 10 minus x, because that's what I know y is. I know y is 10 minus x, and this is equal to 28. So now I have this nice equation here with a single variable, and this is no problem to solve for. So 2x plus, we want to go ahead and simplify both sides. In this case, we need to distribute the 5, so we get 50. And then minus 5x is equal to 28. Let me go up here. So let me combine like terms here. So 2x minus 5x is going to be negative 3x. And we have a positive 50 here. This is equal to 28. So let me go ahead and subtract 50 from both sides. So we get negative 3x is equal to negative 22. And lastly, we're trying to solve for x here, and this negative 3 is a problem. So we're going to go ahead and divide both sides by negative 3. And we get x is equal to 22 over 3. And so it's 7 1/3 essentially, but this is an exact answer. So 22 over 3 pounds of peanuts. Okay, so if you tried the guess and check method, you know, this answer would be hard to come by just by guessing and checking. So this is half of our answer. And, you know, really this is the hard part. Once you get the first answer, the second answer is usually quick to come by, or the second thing we're looking for. So we know x is 22 over 3. So now we could go back to one of our equations. This first one is easy to work with. We know that x plus y is equal to 10, and I just found that x is 22 over 3. So 22 over 3 plus y is equal to 10. And I want to solve for y, so I just need to subtract 22 over 3 on both sides. So I obtain y is equal to, now if you do this off to the side, we're doing 10 minus 22 over 3. This you could change to 30 over 3. And so 30 minus 22, we get 8. And then we keep the common denominator of 3. So if you're not sure what I just did there, I encourage you to grab a piece of paper and just do that math out and see if you get 8 over 3 as well. So y is equal to 8 over 3. And what does y represent? Y represents the number of pounds of cashews. So 8/3 pounds of cashews. And so we have x. Let me go ahead and circle x, and let me go ahead and circle y. So that's what we're trying to do, right? Trying to find how many pounds of each type of nut Kayla should use to make the mixture. That's gonna satisfy the $28, and that's gonna satisfy the 10 pounds. So you could go back and check your answer. If we add up x and y, 22 over 3 plus 8 over 3, that's 30 over 3, or 10. So the weight does in fact equal 10. And 2 times this number, which would be 44 over 3, plus 5 times this number, which would be 40 over 3, is 84 over 3. And 84 over 3 is in fact 28. So you could go back and check your answer just by plugging these into both equations and seeing if it actually works out. All right, so that's the way to check your answer. But once we have that, we're complete. So that's number 1. Now, number 2 and number 3 are going to be fairly similar. So let's go ahead and take a look at example number 2. So example number 2, we have a nurse needs 400 milliliters of a 35% solution of alcohol. She has one bottle which contains a 20% solution and another bottle which contains a 60% solution. How much of each solution should she mix together? So go ahead, feel free to pause this and read it a few times. But what we're dealing with here is containers mixed with alcohol. So we have some type of base, and then the alcohol is mixed in. Now we want a container, 400 milliliter container, and 35% of that container should be alcohol. Now this would be easy, right? If we already had a container with a 35% solution of alcohol, we could go ahead and just measure out 400 milliliters and we'd be done. However, we don't have that. We have, a lesser strength solution, right? This has 20% alcohol, and another one has 60% alcohol. So the idea is going to be to combine these two bottles, right? Combine them into a separate container, and this stronger solution will mix with the weaker solution, and you'll get a solution, somewhere in between. But it depends how much you add of the 60% solution and how much you add of the 20% solution. Just logically thinking, if you took the 60% solution and you poured 99% of this stuff into another container and 1% of liquid from the 20% solution, that's still going to be a solution that's very close to 60% alcohol, right? Because most of what you just poured in was the 60% solution. So we're trying to find a nice balance here to obtain this 35% solution of alcohol. You may draw a picture if you like, if pictures help. Let's go ahead and follow the same strategy that we did for number 1. So we want to be working with some variables, and to do that, we need to name a few variables. And naming variables is a very difficult part for a lot of beginning math students. So my advice here is to look through the question and ask yourself, all right, first of all, what are you trying to find? All right, that's most likely going to be one of the variables. And what other information do you not know? Okay, the information that you do know is not going to be a variable. A variable means that it could change depending upon the situation. But if you're given concrete numbers, that's not going to be a variable. That's essentially a constant. So, like in the previous example, we took a look at the last statement. How much of each solution should she mix together? So we have two solutions, right? This 20% and the 60%. And we need to know how much of each. So we could say let X be the number of milliliters of, let's say X could be the strongest solution. So let X be the number of milliliters of the 60% solution. Okay, so for example, I could take, 200 milliliters of the 60% solution and add it to some other container somewhere. Okay, and how do I know this is milliliters? Well, they're asking how much, right? So how much means we're looking for milliliters here. And go ahead and take a crack at what you think y is going to be here before I say it. So I'm going to say let y be. So we're trying to combine these two things. So y is going to be the number of milliliters of the other solution that we have, the 20% solution. Okay, so this part here is just naming my variables, but it's very important to do this if you want to have a good understanding and grasp of the problem and be able to set up your equations correctly. Because if you don't know what your variables represent, then you may get lucky and you may just memorize the methods, but you want to have a good understanding of what you're doing, and this really demonstrates an understanding. So this I find to be a very important part of the problem. Now, once we have our variables named, we want to go ahead and try to create some equations that contain our variables. Now, to do that, we want to go ahead and take a look back at the problem and see if we could pick out any information that'll help us here. So first of all, a nurse needs 400 milliliters. Okay, and we're combining these two solutions together, the 60% and the 20% solution of alcohol. But whatever we combine, it could only combine to be 400 milliliters. So example, 180 and 220. Or 200 and 200, or 100 and 300. Those are all fine. We don't know how much, so what we have to say is X plus Y, right? The milliliters from the 60% and the milliliters from the 20%, when they're combined, it should equal 400 milliliters. This was kind of like our weight equation in example 1, right? Where we knew the amount of pounds of peanuts and cashews. Now, what else? We have some other information. We need to have this be a 35% solution of alcohol. Now, we need 35% alcohol here. So let's see. Well, we want to create some equation with the alcohol here, and the reason I'm pausing is just because I was looking for a calculator. I may need one. I don't see one about here though. So the second equation could involve the alcohol here. Now we have X milliliters from solution, the 60% solution, right? So could you tell me, if you take X milliliters from that, how much is going to be alcohol? Well, 60% of that, right? So 60% of X is the amount of alcohol from the first solution. And what about the second solution? I'm going to take Y milliliters, and how much of that will be alcohol? Well, 20%. So this is an amount of alcohol, and this is alcohol here. When we add this together, we want how much? Well, it's not 400, but 35% of the 400 milliliter container needs to be alcohol. So 35% of 400. Okay, so this amount of the second equation here is saying, all right, I'm going to take this amount of alcohol and this amount of alcohol, and it should equal this amount of alcohol. So those are the two restrictions that we have in this word problem. One deals with the milliliters, the other deals with the amount of alcohol we should have in the final container. So now we have this nice system of equations with two missing variables. And since we have two different equations, we're going to be able to solve this system through either substitution or through elimination, or even graphing if you'd like to graph this and see where those graphs cross. So I'm going to go ahead and do this by substitution again. The reason I'm doing that is because just this first equation is so easy to solve for one of the variables. I could do the same thing. I could solve for y for this first equation, say y is equal to 400 minus x. Right, how do I get that? Well, just minus x from both sides. And then I could take this and replace it right here, and we'll have a nice equation just involving x. So now I'm going to rewrite my second equation, which is 0.6x plus 0.2. Now instead of writing y, I'm going to go ahead and put my replacement, which is 400 minus x. And this is equal to, so let's see, what's 0.35 times 400? So that would be 35 times 4, or 140. Okay, because 35% of 100 is 35. And then essentially what we have here is 4 100s. So then you multiply the 35 times 4 and you get 140. If you have a calculator, you could just go ahead and put that in your calculator and see what you get. Okay, so now let's see what we have. We need to clean this up a bit before we solve for x. So if we can, we want to simplify the left side, and the right is as simple as it could be. So we're going to have 0.6x plus, now 0.2 times 400 is 80. And then minus 0.2x, and this is equal to 140. So I'm going to keep my variables on the left. So we have 0.6x minus 0.2x, which would be 0.4x. I'm going to subtract the 80 from both sides, so we obtain 60. Now we need to go ahead and divide by 0.4 on both sides. And so dividing by 0.4 is the same thing as multiplying by 2.5. So x is going to equal 150. And what does x represent? Well, that's the milliliters of the 60% solution. Okay, so milliliters of 60% solution. Okay, great. So now this is half of our answer. So let me circle this answer here. Now the other half, we need how much of each solution? Well, we know 150 milliliters of the 60%. Now what about y? Well, we have this nice easy equation. We know x plus y is 400. And I just found x to be 150. So instead of writing x, I'm going to fill in the 150 and then solve for y. So we just need to subtract 150 from both sides, and we obtain y is equal to 250 milliliters of the 20% solution. Okay, so if you want to go ahead and check your answer, you could plug x and y back into these equations. The first one's easy to check. 150 plus 250 is 400. And the second equation, 0.6 times 150 is 90. And 0.2 times 250 is 50. And 90 plus 50 is 140. and 0.35 times 400 is 140. So this one works out too, so that's not too bad to check either. So, all right, so that's number 2. So again, the setup is involving these equations in standard form, right? Ax plus by is c, and ax plus by is c. In this case, the c was the 140. Now let's move on to a different problem, right? Example number 3, we're dealing with some investments. Okay, so this one's a lot to read, but the setup is going to be similar to example 1 and 2. So Marcel has $2,000 to invest in an IRA. His financial advisor suggests grade A bonds, which pay yearly interest at a rate of 5%, and grade B bonds, which pay yearly interest at the rate of 9.5%. His advisor suggests diversifying by putting a portion of the $2,000 in each of the 2 types of bonds. So, why would he do that? Well, the grade A bonds are less risky bonds, so they're going to pay out a smaller interest rate because there's less risk associated with a grade A bond. Grade B bonds are riskier bonds, so they're going to yield a higher rate, a 9.5% rate in this case here. So you don't necessarily want to throw all your money into the more risky bonds just because it pays a higher interest rate. And this is why his advisor is suggesting that he diversify by mixing up his money between the less risky bond A and the more risky bond B. Okay, so he's going to get a combination of this percentage here. So that's in case you're wondering, why doesn't he put all his money into bond B? He gets 9.5%. But it's a more risky bond. You're not guaranteed to get your money back with bonds. So this is the situation here. Now, Marcel decides that he wants a 7.5% yield overall. Okay, so he's going to want to mix between these 2 bonds. So how much should he invest in each grade of bond to meet this goal? Now, again, as in example 1 and 2, I suggest if you want to name your variables, take a look at what they're asking for. In this case, how much should he invest in each grade of bond? So, like in the previous cases, we would say let x equal the money invested in, let's have this be bond A. And what do you think y would be? Let y be the money invested in bond B. Okay, so now we have our variables set up, and with these variables, hopefully we could try to write some equation. Now, one equation comes from the fact that he only has $2,000 to invest between these 2 bonds, and the problem does assume that he's going to be spending all of this $2,000 to invest. He's not holding any of the money back. So that's just something you have to assume with the problem. When it tells you he has a certain amount of money, it means he's going to spend all of that $2,000. He's not going to invest 500 in A and 500 in B and keep 1,000 for himself. While that is, that's an option, it's not the options that are being suggested here. So if he spends X, if he invests X dollars into A, and he invests Y dollars into B, and you add that money together, how much does it have to equal? $2,000. So X plus Y is equal to 2,000. So nice and simple, just like the other 2 examples. I can't say this is going to be the case for all these mixture problems that you'll have a simple equation like this, but a lot of cases you do, where it's just if you add your variables together, there's some restriction on that investment, or on the 2 variables. So now we want to write a second equation because one equation is not enough to solve this. So he invests X dollars into bond A, Now you may want to ask yourself, how much money does he earn on that bond? Well, grade A is going to pay a yearly interest at 5%. So whatever he invests, if he gets the money back, he's going to get 5% interest. So 0.05x, this is the interest that he earns. Now, how much interest does he earn on the Y, right? Y dollars are invested in bond B, and he's going to get an interest rate of 9.5%. So that's 0.095. And be very careful with these percentages too. When we go to work through the problem, we need to have these percentages converted into decimal form. So 5% is 0.05 and 9.5% is 0.095. If you want the percent to decimal, you just need to take this and divide by 100 to get that. Now, this is the interest from A and this is the interest from B. If we add those together, we want, we have a goal in mind. He wants to earn overall 7.5% of his $2,000. All right, so he wants 0.075 of his investment, which is $2,000. Okay, so this is the interest from A plus the interest from B should equal his total interest overall, and he wants the 7.5%. That's the restriction. Okay, so now we have these nice two equations with two unknown variables, so we're going to be able to solve it here. So we could use substitution to solve this, and I'm worried about this one. I don't have my calculator handy. I may need it. So x plus y is 2,000. So we could go ahead and write y is 2,000 minus x. Or similarly, you could say x is 2,000 minus y, but you'll need to do a different replacement or substitution in the second equation. So we know this. Now I'm going to go ahead and rewrite the second equation, 0.05x plus 0.095, but in place of y, I want to write 2,000 minus x. Okay, so 2,000 minus x. And this is equal to, now 0.075 times 2,000 would be 150. Okay, so whenever you see a multiplication, you could do just easy like this, 0.075 times 2,000. If you have your calculator, you just plug that right in and we obtain 150. So that represents the total amount of interest that Marcel wants overall, right? He wants 150 bucks out of his investments. So now to solve this equation for x, we just need to clean things up a little bit. So that would involve distributing the 0.095. So 0.095 times 2,000 is going to be 190. And 0.095 times negative x will be negative 0.095x. And this is equal to 150. Okay, now you see we could combine the x values here. So 0.05x minus 0.095x would give us negative 0.04. Wait, is that right? Negative 0.045x and plus 190 is equal to 150. And then we want to go ahead and subtract 190 from both sides. So we get negative 0.045x is equal to, and this would be negative 40. Okay. So now, last step, we're trying to solve for x, so we would need to go ahead and divide both sides by a negative 0.045. So I'm going to go ahead and divide here by negative 0.045. And we see here that if we do this, it looks like we should obtain x is equal to let's see, so this is grade A bonds, right? So this is 888.89, and this is dollars in the grade A bonds. Okay, so if you have your calculator handy, you could just do 40 divided by the 0.045, and you should obtain this answer here. So he wants a little bit less than half of that $2,000 into the safe bond, and he's going to invest a little more money into the riskier bond. So how much more? Well, let's find out. So we know this is x, and now running out of room, but we know x plus y is 2,000, and I know x is 888.89, and this is approximate, that's just rounded. So 888.89 plus y is equal to 2,000. So we would need to subtract the 888.89 from both sides. And we obtain y is equal to 1,111.11. Oh, I missed the 8 here, right? This is 8, 9. Okay, so 1,111.11, and this is dollars in the grade B bond. So that is our solution. Right. So that's it for mixtures and investments. Again, take a look back at example 1, 2, and 3. You could click over here if you want to see those again. I hope you enjoyed this video, and I'll see you in the next one.